Antarctica. A vast, icy wilderness. Towering glaciers meet a frozen ocean. The coldest, driest, and windiest continent. Temperatures plummet far below freezing. Winds howl, powerful enough to knock you off your feet. For centuries, largely unexplored. Early explorers faced treacherous seas. Today, scientists are drawn to study its unique environment. Antarctica is a continent of extremes. It is home to the South Pole, the southernmost point on Earth. Here, the sun disappears below the horizon for 6 months of the year, plunging the continent into perpetual darkness. Then, as if to compensate, the sun remains above the horizon for the other 6 months, creating a day that never ends. The landscape is equally extreme. Antarctica boasts some of the tallest mountains in the world, their peaks hidden beneath a thick layer of ice. Giant icebergs, some larger than small countries, break off from the continent and drift across the Southern Ocean. Life in this harsh environment is a constant struggle for survival. Only the hardiest of creatures can withstand the freezing temperatures, lack of sunlight, and scarcity of food. For many years, scientists believed that little could exist beneath Antarctica's massive ice sheet. But recent discoveries have shattered that notion. Using sophisticated radar technology, researchers have peered through the ice, revealing a hidden world of mountains, valleys, and even vast lakes. One of the most intriguing discoveries is the existence of subglacial lakes. These lakes, trapped beneath miles of ice, are like time capsules, untouched by the outside world for millions of years. Scientists believe that these lakes may harbor unique forms of life, adapted to the extreme conditions. The study of Antarctica's subglacial environment is still in its infancy. But already, it has challenged our understanding of life on Earth and the limits at which it can exist. Antarctica's ice sheet is a sight to behold. It's colossal, covering an area larger than the United States and Mexico combined. The sheer volume of ice is almost unimaginable, containing enough water to raise global sea levels by a staggering 200 feet. That's enough to inundate coastal cities around the world and redraw the map as we know it. This ice sheet isn't some static uniform mass. It's a dynamic, ever-changing entity. It grows and shrinks with the seasons, advancing and retreating as temperatures fluctuate. Vast glaciers, like rivers of ice, flow slowly from the continent's interior towards the coast, carving deep valleys into the landscape. The weight of this ice is immense, pressing down on the landmass below with incredible force. Beneath this frozen expanse, concealed from view, lies a hidden world. Scientists have discovered a network of over 400 subglacial lakes, bodies of water trapped beneath the ice. These lakes, some larger than the Great Lakes of North America, exist in complete darkness, isolated from the surface world above. One of the most famous of these hidden gems is Lake Vostok. Buried beneath over 2 miles of ice, Lake Vostok is one of the largest lakes on Earth. The Antarctic ice sheet is not a static monolith. It's in constant motion, flowing slowly from the continent's interior towards the coast. This movement is driven by gravity as the ice sheet deforms under its own weight and slides over the bedrock below. This flow is not uniform. The Antarctic ice sheet is not just a frozen wasteland. It's a vast archive of Earth's history, preserving clues to past climates and atmospheric conditions. As snow falls and accumulates over millennia, it traps tiny bubbles of ancient air, preserving a record of the atmosphere from long ago. scientists drill deep into the ice sheet, extracting ice cores that can be thousands of meters long. These cores provide a continuous record of Earth's climate, stretching back hundreds of thousands of years. By analysing the trapped air bubbles, scientists can determine the composition of the atmosphere in the past, including the concentration of greenhouse gases like carbon dioxide and methane. The discovery of life beneath Antarctica's ice sheet was a revelation. It challenged our understanding of where life can exist and what it needs to survive. In this dark, frigid world, cut off from sunlight and the atmosphere, scientists found thriving ecosystems. These ecosystems are not populated by familiar animals or plants. Instead, they are dominated by microorganisms, tiny creatures invisible to the naked eye. These microbes, adapted to the extreme conditions, are the true pioneers of this hidden world. One of the first signs of life came from Lake Vostok. The microbes of Antarctica's subglacial lakes have evolved unique ways to survive. Unlike plants, which rely on sunlight for energy, these microbes use a process called chemosynthesis. They derive energy from chemical reactions rather than from light. In the depths of these lakes, where sunlight cannot penetrate, microbes have tapped into a different energy source: chemicals released from the Earth's crust. The discovery of life in Antarctica's subglacial lakes has profound implications for the search for extraterrestrial life. It expands our understanding of where life might exist and what forms it might take. If life can thrive in the cold, dark depths of Antarctica, it stands to reason that it could also exist in similar environments elsewhere in the solar system. Places like Jupiter's moon Europa and Saturn's moon Enceladus, both known to have subsurface oceans, suddenly seem more promising. These icy moons, like Antarctica, are thought to have hydrothermal vents releasing chemicals from their cores. If microbes can survive on Earth by harnessing this chemical energy, perhaps they could do the same on these distant worlds. Antarctica, a land now synonymous with ice and snow, harbors a surprising secret beneath its frozen surface: evidence of ancient rainforests. This revelation, like something out of a lost world, has captivated scientists and challenged our perception of this icy continent. Imagine, if you will, a time when dinosaurs roamed Antarctica and lush forests carpeted its landscape. The discovery came from sediment cores drilled deep beneath the ice. Buried within these cores, scientists found fossilized tree, pollen, spores, and even remnants of ancient tree roots. These remnants, perfectly preserved by the ice, pointed to a time when Antarctica was a very different place. The presence of these fossils, particularly those of trees that thrive in warm, wet climates, indicated that Antarctica was once much warmer than it is today. The evidence points to a period known as the Mid-Cretaceous, roughly 90 million years ago. During this time, dinosaurs roamed the Earth, and the climate was significantly warmer than it is today, even in polar regions. Antarctica, far from being a frozen wasteland, experienced a climate more akin to present-day New Zealand. Temperatures in Antarctica during this period averaged around 12 degrees Celsius or 54 degrees Fahrenheit, a far cry from the frigid conditions we see today. These warmer temperatures were a result of higher levels of carbon dioxide in the atmosphere, which trapped heat and created a greenhouse effect. The discovery of ancient rainforests in Antarctica has not only revealed a warmer past, but it has also provided insights into the biodiversity that once existed there. Scientists are piecing together the intricate web of life that thrived in this ancient ecosystem, from the towering trees to the tiny insects that inhabited the forest floor. Fossilized pollen grains, each with its unique shape and structure, provide clues about the types of plants that flourished in Antarctica's rainforests. These pollen grains indicate the presence of coniferous ferns and even flowering plants, suggesting a diverse and complex forest ecosystem. Section 4. The carbon connection. Lessons from Antarctica's past. The discovery of ancient rainforests in Antarctica holds significant implications for our understanding of climate change. These forests thrived during a time when atmospheric carbon dioxide levels were much higher than they are today, providing a natural experiment on the relationship between carbon dioxide and climate. The presence of these forests, with their ability to absorb carbon dioxide from the atmosphere, suggests that they played a role in regulating Earth's climate during the mid-Cretaceous. However, the high levels of carbon dioxide also led to significant warming, demonstrating the potent influence of this greenhouse gas. Antarctica's past serves as a reminder that Earth's climate is not static. Buried treasure. The geological clues. Beneath Antarctica's icy cloak lies a potential treasure trove of energy resources. Geological surveys hint at vast oil and gas reserves in sedimentary basins off the coasts. These reserves, formed over millions of years, represent a tantalizing prospect. The scale of these reserves is staggering, rivaling the world's largest oil-producing regions. Section 2. The Antarctic Treaty. Protecting a frozen frontier. In 1959, 12 nations, recognizing the unique and fragile nature of Antarctica, signed the Antarctic Treaty. This landmark agreement, now signed by over 50 countries, designates Antarctica as a continent dedicated to peace and scientific research. The treaty prohibits any military activity, nuclear testing, and most importantly, any commercial mining or exploitation of mineral resources. This provision, enshrined in the treaty's protocol on environmental protection, effectively puts a hold on any oil and gas exploration and extraction in Antarctica. The treaty reflects a shared global commitment to preserving Antarctica as a pristine wilderness, a living laboratory for scientific discovery. Section 3. A delicate balance. Weighing economic interests and environmental risks. The debate over oil and gas exploration in Antarctica is a complex one, pitting economic interests against environmental concerns. Proponents of drilling argue that it could provide a much-needed boost to global energy supplies, reducing dependence on traditional oil-producing regions. They point to advances in drilling technology that minimize the environmental footprint of such operations. They also argue that the economic benefits of oil and gas extraction could be used to fund scientific research and conservation efforts in Antarctica. Opponents, however, counter that the risks are simply too great. They argue that even the most advanced drilling techniques carry inherent risks, particularly in the harsh and unpredictable environment of Antarctica. Section 4. A global responsibility. The future of Antarctica. The future of Antarctica and its potential oil and gas reserves hangs in the balance. The Antarctic Treaty is not permanent. It can be modified or overturned with consent. As global demand for energy rises, pressure to tap into Antarctica's resources will grow. The international community faces a critical decision: exploit resources or protect the continent. The decision requires careful consideration of benefits and risks. Antarctica stands as a reminder of our shared responsibility for the future of our planet. Section 1. Hidden depths. The Denman Canyon and subglacial mountains. Antarctica's icy facade conceals dramatic geological formations sculpted over millions of years by plate tectonics, erosion, and ice. Beneath the ice sheet lies a rugged landscape, hidden from view. The Denman Canyon, a chasm beneath the East Antarctic ice sheet, is one of the most striking features. Plunging to approximately 3.5 kilometers below sea level, it is the deepest point on land. A land of fire and ice volcanic activity in Antarctica. Antarctica, often perceived as a realm of perpetual cold and stillness, harbors a fiery secret beneath its icy veneer volcanoes. These geological hotspots, scattered across the continent, provide a stark contrast to the icy landscapes and are a testament to the dynamic forces at work beneath Earth's surface. Among these volcanoes, Mount Erebus stands as a singular presence. Located on Ross Island, Erebus is one of the few volcanoes on Earth with a persistent lava lake, a churning cauldron of molten rock that glows ominously against the stark white landscape. The volcano's activity provides scientists with a unique window into Earth's interior, offering clues about the composition of the mantle and the processes that drive plate tectonics. Shaping the ice. The interplay of geology and ice flow. The hidden contours of Antarctica's subglacial landscape play a crucial role in the dynamics of the ice sheet above. The flow of ice, far from being uniform, is influenced by the underlying topography, creating a complex and ever-changing interplay between ice, rock, and water. Mountain ranges, hidden beneath the ice, act as barriers, diverting the flow of glaciers and influencing the speed and direction of ice movement. Valleys and canyons, conversely, can act as channels, funneling ice towards the coast and accelerating its flow. The presence of subglacial lakes and rivers further complicates this dynamic. A warming continent, signs of change. Antarctica, long defined by its frigid temperatures, is now facing the undeniable reality of climate change. Glaciers retreat, ice shelves collapse, and the delicate balance of this polar ecosystem hangs in the balance. The Antarctic Peninsula has experienced dramatic warming in recent decades. Average temperatures have risen by nearly 3 degrees Celsius since the 1950s. This warming trend is having a profound impact on the region's ice sheet and its inhabitants. One of the most visible signs of change is the retreat of glaciers. The threat from below. Ocean warming and ice shelf collapse. While rising air temperatures are causing surface melting of the ice sheet, a more insidious threat is emerging from below: the warming of the Southern Ocean. As the ocean absorbs heat from the atmosphere, it's causing the underside of ice shelves, the floating extensions of glaciers that fringe the continent, to melt at an alarming rate. These ice shelves, which act as buttresses, slowing the flow of glaciers from the land into the sea, are particularly vulnerable to warming ocean waters. As the underside of these shelves melts, they become thinner and more prone to fracturing, leading to dramatic collapse events that send massive icebergs adrift in the Southern Ocean. Global consequences: sea level rise and beyond. The melting of the Antarctic ice sheet has profound implications for the entire planet. It's injecting billions of tons of fresh water into the ocean, causing sea levels to rise. The rate of sea level rise has accelerated in recent decades. Projections suggest sea levels could rise by several meters by 2100. The impacts are far-reaching, from increased coastal erosion to displacement of millions. Unlocking the secrets of a frozen world. Antarctica, despite decades of scientific exploration, remains a continent shrouded in mystery. Its vast icy expanse, its hidden subglacial lakes and mountains, and its unique ecosystems still hold countless secrets waiting to be uncovered. The quest to understand this frozen world, driven by both curiosity and the urgent need to address climate change, is far from over. Future research in Antarctica will continue to delve into the continent's past, present, and future. Scientists are eager to learn more about the history of the Antarctic ice sheet, its response to past climate variations, and its potential contributions to future sea level rise. They are also keen to explore the hidden depths of subglacial lakes, searching for clues about the origins of life and the limits of its adaptability. Technological advancements. Expanding the frontiers of exploration. Technological advancements are pushing the boundaries of what's possible in Antarctica. New tools allow scientists to access previously unreachable areas and collect precise data. Remote sensing technologies provide a comprehensive view of Antarctica. These technologies monitor ice mass changes and glacier movements. The challenges facing Antarctica are global in scope, and addressing them requires international cooperation and a shared commitment to scientific discovery and environmental stewardship. The Antarctic Treaty System, established in 1959, provides a framework for peaceful collaboration and the protection of this unique continent. Scientists from around the world are working together to conduct research, share data, and develop a comprehensive understanding of Antarctica's role in the Earth system. These collaborative efforts are essential for addressing complex scientific questions, developing effective conservation strategies, and informing policy decisions related to climate change and the management of Antarctic resources. The future of Antarctica depends on our collective ability to balance the pursuit of knowledge with the imperative to protect this fragile and irreplaceable ecosystem. Antarctica, a continent of stark beauty and unparalleled scientific value, stands as a testament to the power of nature and the interconnectedness of our planet. From its towering ice sheets and hidden subglacial lakes to its unique ecosystems and extreme geological formations, Antarctica offers a glimpse into Earth's past, present, and future. The discoveries made in Antarctica have challenged our understanding of life, climate, and the dynamics of our planet. We've learned that life can exist in the most extreme environments, that Earth's climate has undergone dramatic shifts over time, and that the actions we take today have far-reaching consequences for the future of our planet. Antarctica, though geographically isolated, is intimately connected to the rest of the world. The mysteries of Antarctica are far from fully unraveled. As technology advances and our understanding of this complex continent grows, we must continue to explore its hidden depths, unravel its secrets, and use this knowledge to address the pressing challenges facing our planet. Future research in Antarctica will require continued international collaboration, cutting-edge technology, and a commitment to scientific excellence. We must invest in the next generation of polar scientists, equip them with the tools they need, and support their efforts to unlock the secrets of this frozen world. We must also strive to make Antarctic research more accessible to the public, sharing the wonders of this continent and the importance of its preservation with a global audience. Antarctica, a continent dedicated to peace and science, belongs to all of humanity. It's a shared heritage that we have a collective responsibility to protect for future generations. The Antarctic Treaty System, a testament to international cooperation, provides a framework for the peaceful management and protection of this unique continent. We must uphold the principles of this treaty, strengthening international cooperation and ensuring that Antarctica remains a place for peace, science, and conservation. As we face the growing threat of climate change, Antarctica stands as a stark reminder of the interconnectedness of our planet and the consequences of our actions. What happens in Antarctica affects us all, and we must act now to reduce our impact on this fragile ecosystem.